Hello, I'm Neeraj. Today we will discuss about different varieties of attention mechanisms. So in this series, we will compare self-attentions versus sparse attentions. We will consider the word level attentions only, just for simplicity. As you already know that in all attention mechanisms, we use three concepts: query, key, and value. So similarly, we will use the same. And as the property of self-attentions, you already know that in a self-attention, we calculate the attentions on the words of same text. We are not taking anything from outside. We are taking such things in cross attentions or some different varieties of self attention mechanisms. Here we will just go through some mathematical derivations, mathematical parts. If you want to know more about architectural part, like how deep learning architecture working behind the self attentions and how it is connected with mathematical part, you can just watch my previous tutorials on these topics. So let us start. So in this discussion, I will use very simple three-word text: the cat sat. And after that, we just consider like each word contains a separate word level embeddings with dimension 4. So d equal to 4. After that, here you can see that this embedding is taken. And after that, we will use some representation matrix for query, key, and value. As you already know that all attention mechanisms use this. So representation matrix actually represents the weight of neuron responsible for computing these things. For example, in deep learning architecture, if these are the nodes and these are the connecting neurons, so these neurons are actually contains all weights in the form of matrix. So these representation matrix are actually represent such kind of weights. So these are the weights. Here we have taken all those weights randomly, and I have taken equal weight for query, key, and value. You can take different also. After that, the next part is to calculate the query, key, and value part. So in this, for this, we will just apply multiply dot, take a dot product of embedding matrix and this representation matrix. So this will give you this kind of query, key, and value matrix. This is 3 by 4 matrix. After that, the next part of this is to calculate the softmax. For the softmax calculations, we take the query and transpose of key. So here query, key, and values are same. So you can see that softmax and root under d is equal to dimension d. So dimension is 4. So 1 by root under 4. And then this is query same and this is transpose. So we just take the transpose of this same. And after that, you can see that this is the calculation of this dot product and into 1 by root 4. And after softmax, it gives this value. And then now to get the actual attention on those words like the, cat, and set, we will take the dot product of a with the value vector. So again, our value vector is the same. So we take the dot product. So this is just one iteration. I have taken this one iteration related manual computations just to explain things. But what happens after several iterations? This representation matrix and weight, key, and value, and query weight actually updates through the learning cycles through backpropagations. Now we'll try to understand that what is the use of this matrix. So actual game starts from here. So what happens? This actually context vector gives the informations like how much attention weight these three are getting. So here you can see that due to this weight is slightly bigger than this intermediate weight, but little less compared to the last. So this means the sat word sat, the cat sat. So sat word is getting good attentions or importance from the and cat both. So here it shows the highest importance in this context. Similarly, the word is getting importance from cat and set, but not that much high. So the got the second preference, and similarly, cat word is getting equal importance from like a balanced kind of importance from cat and side both. So it is like an intermediate importance. So this is the interpretations of this attention attention based context vector. Now, why we need sparse attentions, or why we need some different ways to compute the attention score. Now, suppose case 1. Suppose you have very large documents. So you already know that a document may contains multiple sentences S1, S2, S3 that may be related to topic T1, and again another set of sentences S4, S5 may be related to topic T2. There may be some relations between topic T1 and T2 and may be related to some concept. So here you can see that a document, if document is very simple, no, it doesn't matter. But in general document, general quality documents, you can observe similar kind of internal means semantics. So in that case, if you take the entire word like a sequence, the cat sat on mat, and then take all the words of all sentences and then calculate the self attention, then what will happen? The first problem will be you will lose this kind of semantic hierarchy or informations that they preserves inside the sentences. Means inside sentence, here you identified that some word is more important, some word is less important. Sentence importance also varies. Again, sentence may be related to topic may be connected with each other. So such kind of informations may not come if we represents all the words of the text, like entire document as a collection or array of word, then you will lose such kind of information. So this is first case. Second case is like, suppose you have a some hierarchical kind of structure like parents, then parents P1, parents P2, then child C1, C2, then C3, then C4. So such kind of situation is there. So in that case, again, if you represents all things like P1, P2, C1, C2, C3, C4, like in a array of words or array of nodes and compute the importance, you will again lose such structural information. Same thing will happen with graph also. Suppose you have a graph with node like this, and you just consider all the nodes, like all the nodes, and arrange them as a array of nodes, then again you will lose this information, structural information. So that's why we use the sparse attention. So in the sparse attentions, what we do, we take some nearest neighbor. For example, we can take these two, then these two, then these two, then these two, then these two, and then these two. So such kind of strategy to compute the attention. Means instead of taking all, we can manage such kind of attention scores. So we try to manage such kind of attention score by using some permutations. For example, in the case of the cat set, we can say that we will use something like some masked matrix, like so. As we have three words, so we have taken 3 by 3 masked matrix. Now it is up to you, right? It is up to you to decide that which level of sparsity you want to achieve. even in the calculation of sparse attention. Suppose we just want one nearest neighbor. We want to consider just one nearest neighbor in the computation of masked attention. So in that case, we say that the cat set means the only cat will influence the for cat, the and set will influence cat, and for set only cat will influence set. So others are zero. So now the changes will happen when we compute the softmax of query into key transpose divided by root under d, that is dimensionality. So in that case, we just take this output and then multiply it, take the dot product with the masked attention. Masked matrix. Now the things are, we have to do these computations and then apply the softmax computations on this result. We will not apply the masked attentions after computing the softmax. The main reason is it will destabilize the system, and several times you will find that you will not get that benefit in the actual computations. So here, after computations, we can see that at these two places the weights are 0. Now to calculate the context vector matrix, we will take that a dash is equal to a dash. We will take the dot product of a dash and v. That is actually query key and value. So value vector, we already have a value vector here that is calculated. So we will take this and multiply it with this, and then we will get this. Multiply means take the dot product and then we will get this. So now we will try to interpret that how this sparse self-attention context vector is different from the traditional self-attention context vector for the same text, the cat set, three-word sentence, the cat set. For example, here you can see that the word the, actually we have a four-dimensional embedding vector. So we can say that feature 1, feature 2, feature 3, feature 4 for each columns. So here you can see that for the word the, this is the highest score. Means feature 1, and this is maybe like a third highest score. So feature 1 and feature 4 are getting the first and fourth highest scores due to the impact of different embedding, different values with respect to other features of cat and set. Similarly, for the word set, the first feature get the second highest value, and relatively all features are getting relatively on average greater values, like feature 1, feature 4. Again, these are also a little better than F2. So for set, multiple features are getting better impact. So this is more impactful. That's why set is more impactful word according to the attention score. But cat is little average. However, its feature 1 and feature 4 gets some good importance. Now we will see that what happens in the case of masking. So after masking, you will find that this feature and this feature are actually the highest among. This is the first highest score, and this seems second highest score. Both are with the, and similarly cat is also getting better score for feature 1 and feature 4, because we can say that this is feature 1, this is feature 2, feature 3, and this is feature 4. So for feature 1 and feature 4, the cat is also getting good score, and similarly set is getting good score for feature 2 and feature 3. So if you see that the is getting the highest importance, but cat is getting little, sat is getting little less importance, cat is getting little better importance. So here you can see that here sat was getting better importance, and then the and cat was getting less importance. But here more number of features from cat is getting better importance. So this kind of changes we are generally observing with the sparse attentions. So the same thing, the, and these strategies are very helpful in maintaining the structural benefits or maintaining very high documents. So that's why we use the sparse attentions with very long documents, and where we have to preserve the structural things, where some few nearest neighbor means words play important role instead of considering the entire word. Because if you consider all word, because generally what happens in NLP, after some distance, after some number of words, we lose the semantic context. So if you consider all words, then it will be just unnecessary calculations and overhead, and it will destroy your system. That's why in that case sparse attentions will be better. Similarly for graph also, it will preserve the structural informations. For hierarchical kind of arrangements, it will be helpful, and for scalability also it will be helpful.